writing it all the way out. So you're going to have either AA, KA, or KK. That the nomenclature. So on the right side is the glucose. On the left side is lactose, sucrose. All I expect you to know is if it's an LF versus an NLF, you should be able to tell me just by knowing if they're LF versus NLF. And A means acid production. And what's our common color things turn on a sugar? Most commonly. Think of your mannitol salt agar plate. What color did it turn? Yellow. This is going to turn yellow. If it turns yellow in the deep, you put an A. All Enterobacteriaceae ferment glucose, so they're all going to have, the right side is always going to be A. If they are a lactose fermenter, and that's all I'm expecting you to know, they're going to be an A. It'll turn the slant yellow, so the whole tube will be yellow. So what do you know then about these three? Just by knowing that they're lactose fermenters, and just by knowing all Enterobacteriaceae ferment glucose, what do you already know about those three? They're AA. Okay? I mean, if you just know that they ferment glucose, that's a common characteristic, and that means acid production. So it turns it yellow. Then you know they're LFs. They're going to all be yellow all the way through. This usually works really good too. We do this in lab. So the only one, so this would be LFs. If you aren't a lactose fermenter, and I think it's one we have in lab called Kleb oxytoca. It does ferment sucrose, so it turns that slant yellow. But right now, I'm just having you know for the test, if it's an LF versus an NLF, what do you have? So you give it the K designation if it doesn't turn the slant to yellow. So the left side is a K, those are your NLFs. Like the ones we had Proteus, Shigella, Salmonella, they would all have, and the media is a pink color, so it would stay pink. So you'd only have the deep end with the yellow. And then guess who is inert like Moraxella? Pseudomonas. Pseudomonas is an aerobic. It cannot ferment glucose because it's aerobic. Fermentation is an anaerobic process. It can only oxidize. So it's going to stay red in the bottom. And it's an NLF. So it's not going to do anything to the lactose. So this is one of the reasons when we do this API 20E, Pseudomonas isn't an Enterobacteriaceae, but it still works on that test strip. And I usually have Laura set up that one, and the rest of you do an Enterobacteriaceae, because the first sugar is glucose. There's 10 sugars out of these 20 tests, and it's all in this really neat little strip. The first sugar is glucose, and pseudo's blue. The rest of the Enterobacteriaceae turn it yellow. So it's a really good one to show you the sugars in a TSI. So on your test next week, you're going to have to know if it's an NLF, it's KA. If it's Pseudomonas, it's KK. If it's an LF, it's AA. Okay? We're only going to have you know that amount. Yes?
Sorry, so that is not necessary to for this flow chart then?
Uh-huh.
It is or it's not?
They can use it. Mm-hmm.
Because if we already know that it's a gamma hemolytic, then it doesn't really matter.
Well,
right?
this would be AA too.
So it doesn't really
Distinguish
anything on this side.
But it's still a common feature. We're going to get to those.
Okay.
They're still coming. But this is something you got to realize, because you still got to be able to distinguish an LF versus an NLF. So if I did it this way, so if I did it this way, you would definitely know these are AA and these are KA.
Does that add any more?
It will, this will be helpful when we add all the non-lactose fermenters. It still doesn't help here.
There's only the 3 then.
It's only the 3. And we can do hemolysis, but there's an indole test going on that I want to use it instead. So what else is in the TSI we still got to talk about? We got the sugars.
Acid and gas production.
So acid would be from the sugars. Gas would be 1. So this would be 1, 2, 3. And how do you know there's gas? And I have a picture. What happens to the auger in the tube if there's gas? It doesn't say at all. No gas production. There doesn't say cracks in the auger in that.
Oh, yes.
Yeah.
In your PowerPoint it did, but in the book, no.
It doesn't say in the procedure either, on a positive. Okay, if you have gas, you're going to either have the whole auger lift up from the bottom and you'll have an air pocket. Sometimes you'll just have little bubbles, big, off to the side that pushes in the media. Any lifting or big air pockets within the media is a positive gas. And then what's the 4th thing? And this is big for something like Salmonella and Shigella. What did the HE, SS, and XLDs also show? And it shows it here too.
H2S.
Yep, H2S production. So guess what? You're going to have not black centers, black, the media turns black. So Salmonella would turn black, Shigella wouldn't. Citrobacter and Proteus are 2 of the Enterobacteriaceae. They're going to turn it black as well. So if you learn anything with H2S in the media, you're going to either have black centers, like the SS, XLD, and HE, or you're going to turn the media black. So on your test next week, you're going to have to tell me what 4 things the TSI looks for, and you're going to have to tell me at least the sugar fermentation on LFs, so you know that's AA, NLFs, you know that's KA, and pseudo. So you're going to have to know that for next week's test. So I'm not going to worry about if you know the gas or the H2S yet, but you got to know this by knowing that all Enterobacteriaceae ferment glucose. You should know every Enterobacteriaceae is A on the right side. If it's a lactose fermenter, it utilizes lactose. If it's a non-lactose fermenter, it doesn't. It stays the color of the media, and that's a K sign. And then pseudo is inert. It cannot ferment glucose. It can't do anything anaerobic. It's aerobic. So you gotta know these 4 things for TSI, and you gotta know those reactions. Okay, so let's show you an example. And remember, this biochemical is one of your PowerPoints on black. So how would this is the 3 we just showed. Which one is AA? Okay, this would be like your lactose fermenters. Is that gas production? Look how much it lifted it. And how they do gas production, if they're writing it, they circle the glucose. If you see a circle on the glucose, that means it's gas positive. So all your lactose fermenters are gas positive. Do they produce H2S? Is there black? No. So you already know the TSI for all your lactose fermenters. AA, circle the glucose, that means it produced gas. And if you don't say H2S positive, you know it's H2S negative. What would this one be? KA. So it's an Enterobacteriaceae that's a non-lactose fermenter, right? And we do have club oxytocin, and that will be confusing because it does ferment sucrose. But I'm going to keep it as simple as I can so you can build on it. This will be what your non-lactose fermenters do. And then who is this? KK. This is what pseudo would look. So we'll make sure we try to do a pseudomonas so you can see all three types. So this one would be, and this one's probably a better Ka. It's a little pinker here and a little deeper yellow. This would be, and this, can you tell, that would either of these have gas production? Doesn't really look like anything. So this is the only one here. This might, if I got to see the tube closer, this could be a gas producer. But without seeing if that's an air bubble with this bar in the way, I would have to say no gas producers here, gas producer here. Would you say any of these were gas producers? No. And they don't have any of the far ones circled. So this would be like our non-lactose fermenters. This would be like our lactose fermenters. Sometimes you will get cracks and it's a gas producer, but these don't look very big. This is truly what an E. coli would look like and an enterobacter with that gas. This would be a lactose fermenter that would produce H2S. I'm not going to have you know any lactose fermenter but those three. E. coli, Enterobacter, Klebsiella. If you come across as you're out working in the clinical, then you can learn it there. This would be how Salmonella would look. It would be a non-lactose fermenter. When it turns the whole bottom black, you have to assume it already did the deep end for glucose. It's going to overwhelm, it's going to overtake the bottom. You just have to assume it was A positive, which is what they did on both of these. They assumed it did ferment glucose when the black takes over, okay? So this would be maybe I don't know really, unless there's one of them that also can produce H2S, this would be the classic one for your Salmonella and Proteus and Citrobacter, because they're all, you'll learn, those are all NLS and they produce H2S. So you've got to know for your test on these three, it's A, it ferments lactose, it ferments glucose, and it also produces gas, all three of them, okay? Doesn't do anything with H2S. So we'll make you just know the lactose fermenters for next week. So who has the next one? Is it indole? Okay, this one I guess I never gave to anybody, it's me. This is your hallmark test for E. coli. If you don't know any other test for E. coli, it's part of the MVIC. So we know, I think Leah, you have the MRVP, and who has citrate? Okay. We have a test. So TSI, you got to know your lactose fermenters for TSI. You already know that. AA, circle. Now the indole is the first letter of the MVIC. These are the classic reactions you got to know for your registry. And I'm going to make you know them for all the lactose fermenters. I won't make you know all 4 tests for all the non-lactose fermenters. But indole is the hallmark for E. coli. It is positive. So in your book on page, we have a little dropper. We don't have the broth, but I showed you both. It's seeing if the organism can produce indole from the amino acid tryptophan. That's E. coli's classic test. If you don't know anything about how to identify an E. coli, you got to do indole. So anybody who suspects they have a beta hemolytic colony on blood that's large and gray, and they have a dry lactose fermenter, and you're thinking you have E. coli, we're going to set up the panel of 20 tests, but you also have to do an extra biochemical. You want to do the indole. We have the droppers for it. It's on filter paper. It is its classic test. So E. coli is positive Kleb and Enterobacter are negative. And a little clue, they're usually, when we get to Leah's, hers are fermentation pathways. MRVP. You're not gonna be both. You're gonna be one fermentation pathway versus another. You're not gonna do both. So I stands for indole, M stands for methyl red. V stands for Vogue's Proskauer. C stands for citrate. They call it MVIC. We at least have the I, we have the C. We don't have the methyl red Vogue's Proskauer reagent. So you can at least do 2 of the 4 tests if you have these 3 lactose fermenters on your unknown. So you always have to do some biochemical. You can't just set up the API 20E, get your code, identify it, and then read your Kirby-Bauer for your antibiotic. You gotta do another. So you know you're gonna do oxidase because these are all oxidase negative. You know you're not gonna do the catalase like we did for the gram-positives. You're gonna do the oxidase to make sure they're oxidase negative. Then, after you set up your API 20E, get it in the incubator, you're gonna set up another biochemical that proves this organism, okay? Because you've got to know the biochemicals for your certification exam. You might know your biochemicals better than some of the techs in micro. Because they're so used to just, oh, gram-positive, I'll put it on the Vitec. Oh, gram-negative, I'll put it on a card for gram-negatives. You might know more biochemicals. Now, if they've been working in the department 30 years, they're going to know everything. But if they're new, you might know more, unless they just took their test. Okay, I don't know if our spot indole turns blue, but I think it does. So you'll get a little filter paper, and you'll put the colony on and do the spot. Usually it's either you put the drop on and then you rub it in, or you put the colony on and then you do the spot. So we'll see what the insert says. The book talks about a tube method. The only thing I want you to take away on the tube method, it turns the top red. I think that's what it says in your DeLost. I think it says it's a red, because I think this Kovacs reagent, when you add it, is no color development for a negative, a positive reaction is a red ring at the top. So I don't think anybody will do a tube media, but at least it's usually a red ring. This is its hallmark test. Okay? So the next one is the MRVP, the next 2 tests in the MVIC.
In the MR, I guess there's 2 pathways. In the MR, the acids decrease the pH, which makes it red.
Okay, so it's a red color as well.
And then the VP, acetylene?
It's another pathway
Yeah,
of fermentation.
It turns into diacetyl,
It turns into, what's the color?
which turns into a red color.
So we've noticed if you do a tube method for any of these, the tube would be red, this would be red, this would be red at the top, okay? So if we had the tube methods, the end all, we'll probably see the little pretty bluish green color with the filter paper. Most labs, if they're gonna do any kind of test, are gonna do these spot tests. Kind of like the PYR, kind of like the oxidase, kind of like the indole we'll see today, or we'll see next week. Okay, so remember, you're one or the other fermentation pathways. You're not both. So you kind of split it like this, at least for the lactose fermenters. So who's positive for methyl red? Does it give you a positive at the bottom of the?
Yeah, positive for methyl red is E. coli.
Okay, so what do you think these 2 are? So you already are getting, you're probably gonna have plus, plus, minus, minus, negative, negative, plus, plus, negative, negative, plus, plus. So is it saying VP is positive for Enterobacter and Kleb?
Yes.
Okay? So you know there's a little pattern here. So you're already finding the biggest way you're going to distinguish E. coli from the other two is going to be indole. So that's why I would rather do indole than hemolysis here. And then underneath here you can put beta. But indole is its classic test. Here now you have Kleb and Enterobacter. So can we distinguish them yet? No. But we're getting there. We have two tests we're going to get to that we can distinguish them. So that's what the methyl red would look like. It just turns it this reddish color. So we know the indole tube turned red, the methyl red turned red, and the VP turned red. So this is the citrate. Who had citrate?
But it differentiates lactose fermenters that utilize citrate.
As its sole carbon
Carbon
source.
So the lactose fermenters that use that is Kleb, and that we turn it blue. It
Okay.
turns-
Yeah, this bluish color, that means it's positive for citrate then.
It converts the sodium citrate to ammonium hydroxide.
Okay, so Enterobacter should convert it too. So now you know, you've got to not only know the TSI reactions, so you know you have AA circle for all three LFs. And now you know for next week's test, you got to know the MVIC. Okay? You have to know plus, plus, minus, minus for E. coli, and minus, minus, plus, plus for Kleb and Enterobacter. Okay? So who had the next test? Next page. This is one of them that you can distinguish.
I did. I had
Oh shoot, I don't want that one yet. What'd you have?
motility.
Okay?
So basically the purpose of this is that you get a small piece of agar and you're looking to see what bacteria is motile or not.
I think this is a tough test to
Um,
see. It's easy to do. Well, unless you have unsteady hands.
It says the Shigella and Klebsiella, those are the non-motile and they use those as the
Keep that in mind. The only two, there's a Yersinia.
Yes, yeah, this Yersinia, sorry, it's motile
At
at 22 degrees Celsius.
but at
yeah,
37, it's non-modal. And is it enterocolytica?
Yes, enterocolitic.
Yep, it's a GI one. This is a big test that you can utilize to distinguish. Most of them are modal. So it's a real easy test to do other than if you have an unsteady hand. And I'm thinking it'll be a media across. So it's a tube media. And we have some loops, or we take the back end of a loop that is just like it's not a loop on it, it's just like a point. You pick up your colony and you go straight down and straight up. So if you have a shaky hand, the hardest part is going straight down and then straight up. Does it say what a positive shows?
It did, sorry, it talked about it,
What does it do along the stab if it's modal?
it reduces it to red pigment, is that?
Well,
why we're in
it
that
should do cloudiness throughout the whole tube away from the,
Oh.
so it should grow all away from the stab. If it's non-modal, it only grows down the stab. It shouldn't be cloudy away from it. I think this is a tough one to see though.
Okay.
So I would recommend the next test we're going to talk about. But now we know one of the ways to distinguish Kleb and Enterobacter, if it's positive, it's going to be Enterobacter. If it's negative, it's going to be Kleb. So if you remember which ones are non-modal, you just know the others are all modal. So you got to think. Klebsiella, you are going to see it's non-modal. The other one that's non-modal, Shigella, on a stool culture, you're going to see. And then Yersinia, there's one called pestis that caused plague. Well, plague's been pretty well eradicated, but Yersinia enterocollitica, it's like our last genus, it causes gastroenteritis. So at certain temperatures, it's non-modal. Okay, so we know one way to distinguish them. The next one I want to go to is urease, because that's something you're going to have to know for your test, because there's some left that I'm not going to make you know for your test. So who has urease? Okay. This is my other favorite media.
Urease is splits the urea molecule into ammonia, carbon dioxide, and water.
There's two key ones that create urease or make it. Which two are they? And which one is fast versus which one is slow?
Protease is the rapid urease producer, and Klebsiella pneumoniae or the slow.
Okay, so it turns this beautiful fuchsia. It is really pretty, kind of like mannitol salt agar. Whoever has a potential LF that is gamma, you're going to want to set up a urease, because I think it's easier to see than motility. Well, so my recommendation to be able to tell it, but it's not the same for both. So you'd have to say urease is negative for Enterobacter and it's positive for Kleb. So you can't do the slash, and they're not both positive. So I don't care if on your test you just put one, but this is what you got to do for next week's test. You have Haemophilus, and you have the 3 lactose fermenters that you got to do on a flow chart. I don't care if you do motility on the flow chart or urease on the flow chart, but on your practical, whoever thinks it's Kleb or Enterobacter, if we have it left, I would do urease. And the other thing, anybody gets a Proteus on their practical, you want to do the urease, because in 20 minutes you may get to see the pink color in 20 minutes. So you don't have to sit there and wait 24 hours on a Proteus. A lot of times it changes that fast. Yes?
Is the test over at urease, is that a MOT?
Urease?
Oh,
Oh,
okay.
motility, sorry. But remember, they're not the same reaction, so you can't put plus and put by either slash motility urease, because they have different ones, okay? And on your, I'm going to give you credit if you use one or the other. But I notice a lot of you, and I appreciate your work, you guys. I mean, you gotta still put all this to memory, and it's a lot of material, and by the end, you gotta then use it all for one big test. So you've been very detailed on your flowcharts, and I appreciate that. You put almost everything that can be done, and that's awesome. So it doesn't go unnoticed. I really appreciate that you really try. Yes.
Do we have to do both indole, or can we do one or the other, indole or the methyl red then?
On here,
Yeah,
you want to do indole. You got to know E. coli is classic indole.
so we don't need to do methyl red.
Oh, you're going to have to know this,
Oh,
but it's not
okay.
going to be in the flowchart. You
Okay.
got to know that though. Yes.
Where is the Shigella and the Salmonella? Is it on the NLF?
NLF side. We're going to get to that next week. I'm breaking them.
Okay.
We're going to do NLFs next week. We haven't even got to disease stage yet. So this is the butt kicker chapter. So I try to break them for you. So that's going to be our biggest flow chart. And yes, you will use motility, because what? Salmonella is modal, Shigella is non-modal. But what else helpful between those two that is easy to see? H2S. You're going to do something for Salmonella that is H2S positive, and then you don't even have to use motility because Shigella is H2S negative. I feel motility auger is very hard. I mean, we try to pass around a positive and negative. I still think it's hard.
We have it.
We have it. But I think it's hard. But it's okay to know it, because there's hardly any that are non-modal. So you want to know it. And they'll put it in their little case studies, and it's a big clue. Okay, so you got to know your MVIX. This isn't part of your flow chart. You got to know your TSIs. This just questions. The flow chart, I am perfectly fine. And these you would have to put gamma. And I could see you putting on, this would be the dry McConkey. This would be the wet or mucoid McConkey. Those are all clues.